Good morning to all. This is the Southeast Welding Academy. My name is Welding. I'm your AWS certified welding instructor. And today in this video, we're going to be going over travel speed. So the first question we're going to answer, what is travel speed? Your welding travel speed is the rate at which your welding torch, electrode, or welding head moves along the joint during welding. Usually measured in inches per minute or millimeters per minute. If your travel speed is too slow, this can cause excessive heat buildup. Your weld bead becomes wide and tall. You have a high chance of burn through, especially on thin metal. You increase your distortion rate, and overall you can come out with a weaker weld. While on the other hand, if your travel speed is too fast, you might not have enough heat input. Okay, your weld bead becomes narrow. You got a lack of fusion or undercut at the edges of your bead or the toe of your weld. You got shallow penetration, meaning very poor penetration, and possible porosity due to trapped gas. When you're done welding, how do you know you had the correct travel speed, right? What the weld should look like, right, with correct travel speed procedures. Oh, hold on. When you're done welding, how would you know if you had the correct travel speed, right? If you were using the correct travel speed, right? What your weld should look like, or what travel speed produces, what the correct travel speed produces, it produces a smooth, uniform weld, an even ripple pattern, okay? Good penetration without undercut or burn through. There are a few different factors that can determine your proper travel speed, right? So different type of metals and different type of positions and joints, this can bring you to using either a faster, travel speed or slower travel speed, you know what I'm saying? These are a couple of things that can determine the proper travel speed, right? So first on the list, we got your welding process, whether that's MIG, TIG, or stick, right? Second on the list, we got your metal thickness. Third on the list, we got your joint type, whether that's a butt, fillet, or groove weld. Your welding position, right? Flat, vertical, or overhead. Your material type, steel, stainless, or aluminum. And your amperage and voltage settings, right? With thicker metal, you will want to use a slower travel speed. With higher amperage, you'll want to use a faster travel speed, if possible, right? With more heat-sensitive metal, you would just adjust your speed to avoid distortion, meaning burn through, your welding defects. Now I'm about to show y'all a couple different beads. I'm gonna show you the defects of what happens when you're going too fast. Right? I'm gonna say this again. Your heat input equals your voltage x your current over your travel speed, right? Okay, so I'm gonna show y'all a couple beads, right? I'm gonna do some with my travel speed fast and a couple with my travel speed too slow, and a couple with the proper travel speed, right? So I am doing a flat position, just for the sake of this video and the sake of the practice. I'm gonna run two too fast, then I'm gonna run two too slow, and then I'm gonna run two with a proper travel speed, right? So already knowing that in the flat position, I would want to have my amps at about, okay, we're not gonna go over current in this video, it's just travel speed. So because I'm doing welding flat, I'm gonna just put my amperage or my welding current up to 120 or higher, right? So I'm gonna set my welding. I did this already, but just for the video, my ground is good, my stinger is good. Okay. Y'all not gonna be able to see exactly what I'm doing, but after I'm finished welding, I will bring y'all close to see. Okay. Okay, so for the first bead, what what I'm basically going to be doing is I'm going to be, what a fast travel speed looks like is you're moving too fast, meaning you leaving your puddle. You might be leaving your puddle. You might just be dragging your puddle around, not getting the full penetration. I'm going to show you guys what it looks like. Right here. Okay. I'm welding flat, so I'm gonna get this. I'm gonna try to use an angle like this. Usually, I go for, if I was going vertical, I go for something like this. Okay. This is kind of new to me right here, but I'm gonna try it real quick because my workpiece is just like love. Okay, so this bead is going to be with a travel speed that is too fast. So I got my puddle, y'all can't see, but I got my puddle, but I'm not waiting for my puddle really to get everywhere. I'm kind of just moving. I'm carrying my puddle, but I'm just carrying my puddle up. You know, I'm not really getting the complete puddle, right? Before I start moving up, right? I'm just carrying. Right, and when you have a fast travel speed, your bead comes out more narrow, meaning more skinnier, you know? You move faster, you have less penetration into your metal, or either your base metal, your parent metal, you know, your workpiece. You have very full penetration when you move fast. When you have a fast travel speed. Ooh, it got hot. Right? I'm surprised I completed a whole bead all the way up. But that just shows you how fast I was going. Okay? Please don't mind my overall straightness, okay? But you look at this bead, you can tell that it's kind of skinny. You know, you won't be able to tell probably until I run a one with proper travel speed, or the ones with wide. I'm at too slow of a travel speed that will come out too wide, okay? But looking at this bead with a fast travel speed, you can tell that it's skinny, you know? I am a good welder, so I was just forgetting, you know what I'm saying, to go fast. But you can look at the size and you can see a lot of undercut, right? That comes from moving too fast, moving my puddle too fast, not really letting my puddle fully generate, basically, and then moving up, okay? So that's a quick rundown. I'm about to run one more with a fast travel speed so you can see the similarities. When you run too fast, or with a travel speed too fast, everybody will know, okay? When you run with a travel speed too slow, everybody will know. Okay, let's run our second bead with a fast travel speed. I get the rock. Let's run our second bead with a fast travel speed. This one, you feel? It's like back on track, back on track. Okay. Did my puddle, I'm holding my 1/8 inch of a dot from the plate, and I'm just moving forward. So y'all, one of my alarms went off, man, and the video stopped mid me talking and everything, right? So I'm gonna go ahead and break this. Gotta practice slow. Okay, so I'm really just focusing on fast travel speed. faster than the last one. Y'all see how I'm covering my hand so it don't come up and hit me in my face. Be safe first, man. All the time. It's a little bit more slag. So perfect example of too fast of a travel speed. You see how they're both skinny, you know what I'm saying? Both have a lot of undercut in them, around them, you know. See all that undercut right here? That comes from going too fast. Now I'm out to run too slow of a travel speed and show y'all what them look like. So already we know, like I said, these beads are gonna come out real wide, you know what I'm saying? Maybe real tall, depending on how slow I go. Okay, we know that already, so just look out for that. Alright, so now I'm gonna be using too slow of a travel speed. And maybe I might get stuck by doing too slow. Overly in my puddle. I got my puddle now. I'm just sitting. Not really sitting. I'm going up, but I'm entering it. You know? Entering up very slowly, but slowly. Keeping my rod on the line. Takes to get to the top versus the last two when I was going too fast. See, I'm going there to my half of my rod, you know. When I was going too fast of a travel speed, it took me a rod or under a rod, you know. This rod, I'm a little bit halfway to the top, and my rod is almost out. Too close for comfort. I'm gonna terminate that. Now I gotta go get some more rods, so I'm gonna pause this and be right back, let that cool down. Alright, we back before I finish going up with this wheel. I'm gonna take the slab off and let y'all see what it's starting to do. So y'all already see how long this takes. This is a perfect example of too slow of a travel speed, right? And if your bead will turn out too wide and tall, okay? You guys see that? How wide it is compared to these when I was going too fast. See, I got, when we're going too slow, you do get more fusion. So that's why you see less undercut on the sides, right? You see less undercut on the sides, right? Because you took more time, right? You see undercut right here because you took less time going fast, okay? So if going too slow, you do get a good bead, but you keep how high it is compared to those right there, how high it is, how tall it is, you know? You get good penetration. You may sometimes get excessive penetration though. Y'all peep how wide it is, you know, and how tall it is, right? I'm gonna finish this up, do one more, and then show y'all what a proper bead looks like. What a proper bead with proper travel speed looks like, okay? inching up real slow. So I got my puddle. I'm getting my complete puddle, but I'm just getting real slow. You know, going up real slow. Keep how long it's taking me to finish this wheel, opposed to the last piece. Like this one bead might take me three whole different election wheels. I gotta change my angle. Like that, right there. Right, so I'm gonna just keep it on. Excuse my arch plug right there. Keep it on so I don't waste the rod. Right, so about 3 rods. Take me up to the top. I think I might just do one. Excuse my arc strike, excuse my tie-in when you guys see this. But overall, you see how tall it is when you go too slow, when you have too slow of a travel speed, and you guys see how wide it gets when you have too slow of a travel speed. When, like, the whole time I'm running too slow. With a too slow approach. Just keep that in mind. Alright, y'all look at this. Y'all see how wide it is compared to this one? To these two right here. The first two, too fast. This one, too slow, right? I'm gonna run one more too slow, and then I'm gonna run proper one with a proper travel speed, and you guys gonna see the difference. See how I got stuck, going too slow, getting too long in the puddle.
overly taking more time in the puddle than I need to. Usually, once you see your puddle is fully, generated, and when you see that you've got full penetration, complete penetration between your metals that you're welding, or between your workpiece, then you will just move up. Once your full puddle is there, then you'll move. Keep your rod moving so you won't get burned through.
But because I'm going too slow or using too slow of a travel speed, I'm just, once I get my puddle, or once I realize I got my full complete puddle and I'm getting the complete mixture or the complete fusion, I'm just still sitting there a little longer than I have to, and that's just going too slow. Okay?
You move too slow, start getting stuck.
Look at that slag bill. Y'all see that? Look at that slag bill. Who's a good girl? Let me show y'all that slag bill. Look at that jump. Look at that jump. Yeah. Say no more. We gonna crack that off. I'm gonna go weld this, so I'm always gonna have a good bead. It's always gonna look good. Y'all see how wide that is again, once again. Tied them in a little bit, but y'all still see how wide that is, right? How wide that bead is compared to going too fast, right? So, like we said in the beginning, right? Before I ran even the first one, we would get going too slow of a travel speed, right, will result in a wider bead, right, and a taller bead, right? You see how tall that is compared to these right here? How tall that is, right? Look how tall that is. Okay. Now we're gonna run 2 beads with a proper travel speed, and you guys gonna see the width and the height difference, okay? What I'm looking for after I run, this bead with proper travel speed, what I'm looking for is it to be, I'm looking for my bead to be smooth and uniform. I'm looking for an even ripple pattern and good penetration without undercut or burn through, okay? So let me show you guys that. Gloves back on. I just changed my I just try new stuff. I just be trying stuff different. Y'all get it. I just lost my whole That was me, my bad.
right? So y'all can see what I see. But once I got my puddle, right, that's when I'm gradually moving up, right? But I'm waiting for my complete puddle. Just how if I was going too slow, I'm waiting for my complete puddle. But I'm not, as soon as I get my complete puddle, right, I'm gradually moving out of my puddle up, okay? Never leaving my puddle, staying in my puddle, making sure I have no undercut, getting the complete groove, the complete mixture. Right? This one might not be as straight as I thought it would. It's not straight, guys. And I need some more rods. Like this. Kind of ran it too close, but y'all can still see. No, I think I ran it too close because y'all can't see, you know, the one side of the picture really how I want y'all to. Let me show y'all this anyway. Look at the difference between too fast of a travel speed, too slow of a travel speed, proper travel speed. You see the difference in between the width, right? The height, right? Look at it. Peep, you got the even ripple pattern, right? Look at that pattern. That's not even. Look at that. That's not even. Okay? You get the even ripple pattern all the way up. Okay? I'm gonna run two more over here, right? I'm gonna just leave that one. I'm gonna run two more. I gotta go get the rods. I'm gonna run two more over here because I want y'all to actually see, you know, the spaced out difference. Alright, y'all see over here is too close, so I just feel like y'all can't see it. Okay. Alright, y'all, so we gonna run two more. We gotta hurry up. So I apologize if I start rushing. So what a proper travel speed looks like is I'm staying in my puddle. You know, I'm getting a complete fusion, meaning a complete mixture between my filler metal being my electrode and my base metal or my workpiece. As soon as I get that complete fusion, that's when I gradually move up. Use my arc short. I don't think this is in it. It doesn't feel like it's very secure. Guys, make sure y'all think about electrode and your fingers are secure because they're coming out with the connection. Keep in mind, right, when I was going too fast, when I was using too fast of a travel speed, it only took me one rod to finish one whole bead, right? And that goes for both of them. When I was running too slow of a travel speed, it took me 3 rods to finish my whole bead, right? One bead for both of them. It took me 3 rods to finish both, okay? For when I'm using a good travel speed, meaning proper travel speed, right, it only takes me 2, right? So just as I finished that first electrode, it took my bead to halfway, right? It took my bead
to the half of or what am I saying? It took my bead to the middle of my beat split or my practice split. Y'all see the resemblance and this one, right, with proper travel speed, and this one with proper travel speed. They both have that even ripples. I mean that even ripple pattern, right? Minimum undercut on the side, right? It's not too wide. It's not too tall. Don't mind this right here. I had restarted. Okay. I'm gonna finish it out. Yes, these rods are a little warm, okay? But they're not hot. They're not hot to where they're gonna go.
Yeah. Huh? What happened? Talk to him? Okay. Woo. Okay. Oh, I gotta show y'all that slag peel. Who's a good welder? Who's a good welder? It's like, nah, let me chill. But y'all see that slag peel right there? Yeah. So y'all really are getting the concept. I know y'all are of what it looks like to have proper travel speed. What it looks like to have, you know, too slow of a travel speed and too fast of a travel speed. Let's go over this one more time. Actually, let me do one more, and then we'll go over it. One more. It's like nah. But let's add some humor in this junk. You know, I be watching other welding instructors online. They be having a whole production team. You know, video cameras. I need that. You know what I'm saying? I need that. Cause I'm a funny person. You know. We're gonna run one more with proper travel speed. Show y'all the resemblance. Show y'all what you should see when you got the proper travel speed. You know, not too slow, not too fast. You know. Just take your time. You got that complete puddle. And it's where right where you want it to be at. When you're ready to move up. Gradually though. You don't jump up like, you don't never jump out the puddle. That's moving too fast. Okay? Don't jump out the puddle. You always stay in your puddle. Ooh, I'm getting close. I love when the back of my hand just starts. No, I don't. I was about to style. I'm styling. I was about to say, I love when the back of my hand start heating up because I'm getting too close to the plate. Nah, that junk. Yeah, you done, it done.
whoo, you just don't know when it's gonna stop heating. You know what I'm saying? So it start heating up. And you be like, man, dang. You know, that feels good, that heat feels good, but it don't. That's the side. Right, get that slab. Look at that. Right, so keep in mind, it took us 2 rods to finish a bead, 1 bead, with proper travel speed. It took us 3 rods to finish a bead with too slow of a travel speed. And it took us 1 rod to finish a bead, 1 bead with a travel speed too fast. Okay. Uh-oh. That's my first mess. This is my first and second mess up today. Yeah. Hey. Slap here. Who's a good welder? Once again, my bad. Y'all see that slap here? I was going too fast, okay? I started going too fast. Y'all see how it got a little flat, you know? I still waited for that complete puddle. You know, I ain't took too long. Look at that. Too fast, too slow, proper travel. And that rounds up this video. I'm gonna give a quick recap. We went over travel speed, okay? When your travel speed is too fast, when you have too fast of a travel speed, your bead comes out, you know, more narrow, meaning more skinnier. You might have way more undercut on the toes of your wheel when you have a fast travel speed. You got poor penetration, okay? Whereas if you had a slow travel speed, you probably will have excessive penetration, okay? You will have a wider bead and a taller bead, okay? And if you had an optimal speed, optimal travel speed, or a proper travel speed, the bead will be just right. You know, it wouldn't be too wide, it wouldn't be too tall, it wouldn't be too skinny. You would have the proper penetration. You won't have excessive penetration or poor penetration. Penetration. You will have the proper penetration. You will have an equal pattern look. You know what I'm saying? And you will have less undercut, less welding defects or distortion on your weld when you use the proper travel speed. Okay. Well, that rounds up this video going over travel speed. Thank you for joining the Southeast Welding Academy. My name is Wisdom Shapar, and I'm your AWS certified welding instructor. And I hope to catch you in the next one or in the lab. Peace.